Hello again, fellow math enthusiasts. Root Beer here with question number 20 on the 2003 Pascal competition. What does question 20 have to offer for us? The people of Evenland never use odd digits. Instead of counting 1, 2, 3, 4, 5, 6, an Evenlander, someone from Evenland, counts 2, 4, 6, 8. They wouldn't use 10 because 10's got a 1 in it. In fact, they wouldn't use any of the teens because they've all start with 1, so the next number would be 20. And then 22, 24, 26, 28. Then they'd skip over 30, 32, 34, and so on. They'd get to 40 would be the next one. Okay. What is an Evenlander's version of 111? Ooh, okay. Well, I don't quite... I would suspect there's probably some sort of pattern into working out what 111 should be. So what I'm going to do is I'm going to write out more terms of the sequence and see what I can get. Okay. I wonder if we're using something like a quarter of all numbers. So we're going to have the real numbers, like the actual numbers, the ones that we should have. I'm going to have those going across the top here. And if I have to make a second line, I will, but I just want to really understand what's going on here. So we'll go up to 15 for a moment. So we've got 2, 4, 6, 8, nothing in the tens, 20, 22, 24, 26, 28, and then 40, 42, 44, 46, 48. So, looks like 40 was with 10. I'm going to guess 80 would be with 20. 15 is going to be 60. We'll have 16, 17, 18, 19, 20. I'll go a little further, 21, 22, 23, 24, 25, 26, 27, 28. So after 60, we get 62, 64, 66, 68. We wouldn't have anything in the 70s. We'd have 80, 82, 84, 86, 88, 90. Oh, no, not 90. It'd be 100. No, it wouldn't be 100. It would be 200. Oh, wow. Nothing in the hundreds would count because they all start with 1. Ooh, okay. So I thought for a moment that there was a pattern. If you look at the multiples of 5, it's sort of a little telling. Multiples of 5, we multiply by 4 to get the right answer. But now once we're at 25... we multiply by 8 to get that. I'm not as concerned about these little numbers in here. So maybe something I could try and do is work out what should 115 be? Okay, what should that number be? So, After 200, we're going to go 202 and 204 and 206, and then 208, and we'll get 220. Oops, that'll be for 30. So it looks like we're sort of repeating, but with a 2 in front. So that's every number. So 25 plus n is just 200 plus whatever the n value was. That's sort of the idea. Okay, so by that reasoning, 49 should be 288. 50 should be 400. And it'll keep going, and we do the same thing. We get up to 74 will be 488. And then 75 will be, when I multiply by 8, we should get 600. And then we keep going, and we'll get 99 is 75 plus 24, so that'll be 600 plus 88, so 688. 100 will be 800. Okay, and 100 plus we want 11, so 111 should be 842. Okay, so we recognized a pattern and we're just extending it. If we had to keep going, we'd jump into the 2000s, and I bet we'd be multiplying every 125th number by 16. That's kind of interesting how the Evenlanders numbers go. But that's D842. And I'm just going to make that a little clearer by putting red around this. Okay. So, yeah. I was going to make a rule, but actually, I was going to say well, I'll make the note that the number 5 to the k translates to 2 to the k plus 1 times 5 to the k. So I think that was an important fact to know. Okay. But yeah, that handles question number 20. I like that question because it required us to understand a pattern, but even in the end, I wasn't able to fully formalize a pattern. I couldn't tell you exactly what 172 would be in the Evenlander system. I'd need to take it and extend the pattern and work it out for myself. Now, I think if we tried, and maybe you can try at home, you might be able to get an actual way to calculate absolutely what the Evenlanders version of every single number would be. And maybe there is some really wacky formula for it. But I like that we weren't able to get a concrete mathematical answer there, but we were still able to answer the question by understanding and extending the pattern really nicely. Okay? So that's question number 20 on the 2003 Pascal. Join me for question number 21, which I'll be taking care of in the next video. I'll see you then.